be recorded?
Yeah, sure. Yeah.
You can say this to the camera.
Okay. I have to say the whole thing, or?
Yes, until this.
Okay. Now?
Now.
Okay. Okay. Hello, my name is Chuck-Ting Ho. The title of my talk is How to Safely Migrate from Pandas to Polars. I hereby agree to abide by the Pycon APAC Code of Conduct and consent to being recorded and streamed. Okay.
Good afternoon, everyone. Welcome to session 5 here in Python TV and Python APAC. Let me introduce myself. My name is Rizal Romi, and engineer and the moderator today. Today is Chuck-Ting Ho, a dedicated contributor of the open source community and founder of the Lines, a Python consultancy that is background in data science and global relations. Chuck is also the co-founder of the Python Data, a beginner Python workshop series founded worldwide. She has served on board of the Euro Python Society and is a fellow and the director of the Python Software Foundation. This talk is geared toward data scientists and engineers familiar with pandas and Python, but new to Polar. Without further ado, please join me in welcoming Ms. Chuck-Ting.
Hey, hello. Thank you. That's a very good introduction. So the talk is about how to safely migrate from pandas to polars. So I need to ask you a question first. Who has used pandas before? Yeah, I hope you do. Who have used polar before? Oh, then, okay. So this talk is probably for most of you, and then for those of you who have used polars, maybe it's a good revision of what you know, and maybe fact check whether we agree on the same thing. So my name is Chuck. My website is chuck.dev. You can find a lot of my previous work and the project I'm involved in and a lot of other things that I do over there. So let's get started. So first of all, let's play a game. So I'm going to talk about some fun fact about polars, and you have to count how many of them you know. So I will ask you at the end how many of them you know, okay? So first, do you know that polars is actually written in Rust? Well, I mean, like, I hope you also know that pandas is not written in Rust, so that's the difference. So the reason of so part of why polars is so popular is that because it's written in Rust, and Rust is compared to Python, is a lower level language. So also it has some rules when you're writing Rust that you have to follow to make it. We call it a memory safe program language. So there are a lot of benefits of it written in Rust, but polars is also have a Python API thanks to PyO3. So if you are mainly just writing in Python, you don't write in Rust, you can still use polars. So that's why this is such a powerful tool for you to use. Another fun fact: polars use PyArrows as its backend. So again, I hope that you know pandas doesn't use PyArrow as its backend. And I remember around maybe 5 years ago, I was chatting with a lot of pandas community, the people who contribute and maintaining pandas, and they're talking about, oh, maybe now like there's an idea of writing pandas like a panda 2, maybe we call it panda 2, that is like, oh, using PyArrow as a backend. But at the end, we have polars instead. So polars is not exactly pandas version 2, but it's like it's a new library, but it uses PyArrow as its backend. Reason why using PyArrow is that PyArrow is a column-based kind of data structure, so it allows a lot of very quick query and a lot of benefits when you're carrying out some of your operation when you are doing some like manipulation of your data. Another fun fact, you actually don't have to put all your data in memory in order to use polars. So how many of you Panda users who have loaded in a CSV or a data set and then you ended up having an error because you're running out of memory? Yeah, we all know the feeling. So polars actually polars, there's a way to use polars. So to avoid that is to use what we call the lazy API, which I will explain later. So so that actually gives polars a lot of power to, instead of like pandas, you have to put everything in memory to work. You don't actually, you're not limited by that if you're using polars. So that's another advantage of polars. And another fun fact, polars support, actually this is new, so I don't know how many of you know this. It supports NVIDIA GPUs. So recently in the newer version of polars, now it supports GPU. So if you have to like carry out some calculation that is, you need it to be fast, you need, maybe there's a large volume of data and you need it to be, efficient and fast, and you use GPU, now you can very easily use it together with polars, because now it supports GPU. So even though it's kind of like new, so maybe, there are some rough edges, but, polars is a very young project. It evolved very fast, so it will just getting better and better. So the last fun fact, which I think is the most difficult fun fact, very niche, is that polar bears are actually not white. So if you don't believe me, see this picture. This is a polar bear that got its fur shaved. So it's actually like the skin is black in color down there. So if if let's say if you have a polar bear as a pet, if you like kind of groom it yourself, you can actually make it look like a panda by strategically shaving it. So it got like black and white color. But anyway, joke aside, let's check. So how many of you got all the facts correct? No, you already know. No. How many of you got 4 of them? No. 3, 2, 1. Okay. I hope that you have got at least 1. So that's good. Now you know all of them. So that's congratulations. Now we gotta summarize what's the difference between pandas and polars. We already mentioned a little bit of them when we do the fun fact checking, but let's have a more detailed look into it. So first of all, pandas is written in Python mainly, but if you look at pandas, if you look into the source code of pandas, it uses NumPy as a backend. And NumPy is actually use a lot of C extension. So that's why pandas is not super slow. Even though, like, of course, now we want something faster. Pandas is quite a mature project. I won't say it's old, but it's very mature. It doesn't mean it's bad. It means that its API is more stable. It's like, it won't change like every release. It changes something that could break your code. So there's an advantage of using pandas in that sense. However, pandas has this limitation. Like I said before, you have to load everything in memory. If you are handling a large data set, sometimes it doesn't work, especially like when you load it in, even though it fits in your memory. But if you're carrying some group by or some aggregation, then sometimes it will just like be very, very slow. However, because it uses NumPy, and NumPy uses a lot of C extension for its operation, it's always faster to use the NumPy, the function provided by NumPy instead of using the Python built-in function. So for example, if you have a pandas series, if you use the Python built-in function sum, so you sum and then put the series there, calculate the sum, it's way slower than just using the series and then .sum, because the method .sum is actually using the NumPy optimized method, so it will be way faster. So that's why Panda is not bad. So far so good. We have used it for like 10+ years, and it's like it may not be the best thing, but it works in most cases. Let's look at our shiny friend, polars. Yay! Okay, so polars is actually, like I said, written in Rust. So there's some benefits of that. I already explained a little bit before. Use PyArrow as backend is considered a better way to handle data. But it's a very new project. So if you are using polars or learning how to use polars, you may find that something that you have been using in the past few months suddenly changed in a new release. So you have to be a little bit more careful. And if you have a project that maybe takes a longer time, make sure you like pin the version and all these things. Otherwise, when you kind of, let's say your colleague build a new environment using the newer version, then some of the code may break. Polars will give you an option to use lazy operation. So in pandas, we have data frame. In polars, we have lazy data frames. So it also have a normal data frame. So those things, we call them eager data frame. So eager means that it's kind of like pandas. Everything will be, carried out immediately when you call a function, or like each step, it will be carried out immediately. So it's kind of more like how pandas work. But if you use a lazy data frame and use the lazy API, so there are some optimization that has been done. It's kind of, most of the time is happening under the hood. We're gonna look at them in detail later. And a lot of times, because of that optimization, it will make your code more efficient, make it faster, and make you able to handle bigger data frames. Polars also allow you to use all your core. So polars, because it's written in Rust, it have the ability to work in parallel. So it uses multiple core at the same time. So nowadays, like your computer, maybe your laptop already have 8 cores. So able to use all of them actually give you the benefit. It could be faster. Again, like also not just CPU, also GPU as well. So if you have a machine, also have GPU, then you can also optimize that. Optimize to use that. So let's look at the lazy API. So you see this very lazy, it's like sleeping. So lazy API, why is it called lazy? Is that because the query are not executed until you really need it. So that means that it allows some query optimization. And also because like you don't load everything in, like, each step you load something in, or each step you use a lot of memory. So it saves a lot of memory space. So you can work with a larger data sets. Also, because, sometimes, let's say if it's not a lazy API, it's an eager API, so it's just like going step by step, whatever you call, and then you just execute. Let's say you have a very heavy operation, you have done it, then the next step you made a mistake, all the time that you spend on the first operation is wasted. But the lazy API, because it will only execute when you see that, okay, I need that, so I need to do this. So it allows you to actually have a whole kind of view of things to see if there's an error, a schema error, then it will catches it before you're actually doing the operation. So it could be more efficient in that way. So query optimization is a very, very good thing because there are some times, by changing the order of your operation, it actually helps you to save memory and also save time, because if it sometimes there's something that's called memory swap that your computer may do. So this usually if you use less memory, actually it's more efficient because it do less memory swap. So that's that's could make things faster. The example of how the query got optimized is like this. So in this code here, what it does is that it's trying to read this Reddit CSV, so it's quite big. And then we will try to filter. So here is the filter, right? Well, this comma is bigger than 0. And then after that, when we return the new data frame, it will make all the name of the column uppercase. Okay. So it's just like 3 lines. It's not that complicated, but we can still do some optimization to make this query faster. So before the optimization, this is what the original. So if in Polars, you can actually look at how the query, is expressed. So this is kind of like the query under the hood. So this is without optimization. You can actually switch off the optimization, but I would highly recommend you don't do it. So here we would read. So we read the file. We will read all 6 columns. So it's all of them. So the star means all of them. So read all 6 columns. So we'll read them all first. And then we'll transfer transform the name of the column to uppercase. And then I would, for each entity, like each row, I would check whether they have the comma is bigger than 0. So then that's the result. So this is bad. Reason being that like it will read everything before it do anything. So what if like this is big and it doesn't fit in your memory? A lot of them actually got discarded at the end. If it's have negative or 0 comma, then it would just be gone, right? So why loading them in the first place? So that's why we optimize it. So when we optimize it, when we read, so this is during when we read the data, we'll make the selection. So we already, so by changing the order, because this one's actually swapping the order, the name of the column can be changed to lowercase at the end. I do the filtering while I am reading the data. So by doing that, I immediately discard the 0 commas or negative. I don't think there's negative 0 commas. I already discard them. So the thing that I kept is the thing that I keep at the end, and I just change the name of the column. So this will actually use less memory and is faster. So query optimization is great, but there's also other difference between pandas and polars. So some of them taking some time to get used to. For example, in polars, there's no multi-index. Pandas have a lot of multi-index, and we have to reset index a lot of times. In polars, there's no multi-index, so there's it won't happen. Also, because polars is not using NumPy as backend, a lot of things that we do in the past, for example, when we put the data from a pandas data frame into scikit-learn or into, let's say you put it in a neural network, maybe in a tensor, all these things, you have to take out the value because the value is actually NumPy array. You can't do that with polars. So instead of just using, sometimes pandas, we'll just like the data frame dot value, take it out, and it is NumPy. We have to, so polars give you a method called toNumPy. So we have to call that method to change the data frame into NumPy array. So we have to do that explicitly. Another thing, there's no lock or iLock, which is something I don't actually like a lot in pandas because it's a bit confusing. So instead of that, we would use the select, like the query that I showed you before. So instead of just finding the location, we'll just use some query to select the data that we want to get. So these are the recommendations for you to remember when you want to have faster code with polars. So first of all, be lazy. Use the lazy API. It doesn't sound very good. It sounds like, oh, lazy, but actually there's an advantage. Like I said before, the query is optimized. It's way faster, so be lazy. Second, like I said, don't switch off the optimization unless you have a very, very, very good reason why you just use the default. Let the optimization of the query be carried out because that would actually help you to save memory and time. Third, don't use Python. So what do you mean? We are writing Python. Okay, not use Python. Okay, so I need to explain. When you are using a custom, let's say in pandas, we would have dot apply, right? You're using a custom kind of operation. You operate on your data frame. You have the option to write it in Python. So you can write a Python and then use it to apply to your data frame. I would highly recommend you don't do it because Python is slow. So Polars is optimized. It's written in Rust. Everything is optimized. It's applied to pandas as well. Like I said, if pandas, you try to use all these methods provided by NumPy instead of using the Python ones. So it's the same. Don't use Python. But what if I really need to do something and you don't give me a built-in option, like Polar doesn't give me this operation finding the distance between 2 points. Polar doesn't have it. Then you can actually write your own Polars plugin to do it. Ooh. How do I do it? Okay, I'm going to show you. Well, not actually show you, but tell you how you can do it. So this is like the rule of thumb. So if you have some custom function you want to apply, first of all, check whether Polar gives you a built-in function to use. Try to use them. So sometimes, you can use the sum, multiply, and all this. If you can combine them and make it work for you, use that instead of writing your own. So if that doesn't work, then the next thing you could try is to write it in Rust. So you can write a Polars plugin in Rust, and that'll be fast. But I know not all of you want to write in Rust, right? Not all of you go to my PyRP workshop, so I know. So there actually someone already did it. There are some community plugins already written. You can go to this link. There's a list of them, like some of them like calculating the distance or doing some geographic things. You can have a look to see if you can find something that is already done for you. So it's way faster. Don't do it in Python. But if you really want to learn how to do it, to write in Rust, and Marco actually have a very good tutorial. You can also use the link to go there and learn it yourself. So choose your own adventure. Another tip I will give you if you want to, again, I don't want to learn new things. It's so complicated. Because, sometimes I joke about that, oh, you can mess with your colleague by changing, instead of import polars as PD, instead of writing import pandas as PD, you can, change it to import polars as PD. Maybe the code will still work, but that's not what you want. It doesn't make, good use of polars and its advantage and make it, really optimal. So you have to really rewrite something to make sure you are using the lazy API, you are doing optimization and, all these things. But I don't want to do that. What should I do? Another option is to use Narwhals. Narwhal is even newer than Polars project. There's a third animal there, see? It's actually a layer on top of Polars and pandas, and even like PyArrows and other like DAS and other things that let you use the same API for all of them. So what you need to do is to just change the backend, change pandas to Polars, and then you can use the same API to do things. So Narwhals is just an API. So it doesn't have a dependency. So when you install Narwhals, it won't install all those data frame library for you. It will just use whatever you have. If you're using Polars, then you can just use Polars together with Narwhals. If you're using pandas, you can use pandas with Narwhals. So it's quite lightweight. So it also have a very clear API. So it doesn't cover everything that Polar is doing. It's a subset of Polar's API. So it's even simpler than Polar's to learn. So maybe the first step you can learn Narwhals. It's also separate the lazy and the eager API. So it's more clear about when you're doing the lazy things, when you're doing the eager things, right? And also it works very well with pandas. It will support the pandas data type as well, because Panda has its own data type. So all of these, thanks to these two gentlemen. Marco is the creator of Narwhals. He also active contributor of Polars and pandas. Richie is the creator of Polars, and I really enjoy using Polars, and thanks to him that now I can do this. So these are the reference. I only have 30 minutes. I can't cover everything I want to tell you. So you can learn something yourself by going to the documentation and also the tutorial there. I hope you enjoy exploring the polars and maybe narwhals. So thank you very much. So this is my talk. I hope we have time for some questions. Otherwise, you can find my details, contact details, my social media on my website here, Check4Dev. And thank you. Oh, by the way, Georgie told me that if you have joined the PSF membership, you can come to me and get a sticker. Oh, yeah, the sticker. Yeah, Georgie can show you the sticker. I have it here, but yeah. Yeah, it's very cute. Questions? Okay.
Begini aja. Oh, gini aja. Yeah. Thank you for the presentation. It's pretty interesting. Thank you. My first question about the polars is that I've used polars before, but I'm interested in the query optimizer. So in Spark, we do have like also the optimizer, like the catalyst optimizer, but the other optimizer called active query execution. So after the query is optimized, then it runs, then get the runtime metadata, and then optimize afterward. Yeah. So is there any feature like that as well on Polar, or Polar just optimizing on the query level?
Yeah, what Polars do is just optimize the query. So like you said before, so the query, so the operation order may be swapped internally, so that when you carry out the query, it's way more efficient. There's actually a documentation page in Polars, so you can see that like Polars give you a built-in method to see the the graph, the compute graph. So you can check like between optimized and non-optimized, like what the changes has been done. Like if you're curious, or if you have something like very strange bug that you think that maybe that's the cause, you can use it to check it. But it's mainly just swapping the order, execution order of the query. So what Polar do is like it will just compile the query, and then if you're using lazy, then it would just like compile and execute.
Okay, just to make sure. So, for example, like join case, right? We won't know the table size until the join is happening, right? So if we optimize only on the query level, we might do like a sort merge join instead of like broadcast hash join. So on Polars, only optimize on the query level. After it was optimized on the query level, it will not change, and it will do that steps. Is that I'm just recapping here?
I think so. Yeah, but again, like you can check the documentation to make sure that it kind of suits your use case. Cool. Yeah.
Thank you. Thank you.
Yeah. Okay. Oh, that's a mic.
Oh, thank you. So I have used Polars before, but I also have used other like in-process analyzing tools before. So like something I noticed when I have too many small transactions, for example, like I have a lot of steps to execute, and in pandas, because all of the steps execute in memory, and then they have a footable representation of the execution. This is why even though a lot of steps, it's still fast. But in Polars, if everything is in lazy execution, then let's say we have 80 steps, I need to I guess I need to optimize 80 steps. Do you foresee that's going to be, the optimization is going to take a longer time? Do you foresee that? Is there a bottleneck if optimizing too many steps, that would be a problem?
Yeah, I would say that like, so I don't know if I get it, your question correctly. It's like when you, sometimes like when you do pandas, when you do exploration, you just do it step by step and then you investigate the intermediate result. It's like, and then when in Polars, then you don't do it, or you do it?
So like, let's say we have 80 steps, like 80 steps of transformations, and then all of them are, right now it's written in pandas, because pandas is like really immediate execution of each of the steps. So it got executed 80 steps, and then each intermediate object got created, materialized in the memory. So that's why it's still fast when it passes the next step. It's like input, output to the next step. But in Polars, you're not executing them for each of the steps. You lazy execution and execute and in the final step, right? If I understand right.
Yeah.
I just wonder if I have 80 steps, I would imagine in the end it's gonna be a super nested query.
Yeah, it will be more complicated, but again, like that's the magic of Polars, that it will look at your all these steps and then see like what the result could, because sometimes you swap the order of your query and it will still give you the same result. And then, but the advantage of swapping them is actually making it faster, because it may cut some, like, oh, maybe swapping this to you use less memory for the intermediate steps. So that's why looking it together as a grand scheme of things sometimes like it's better than like just doing it like step by step by step by step. Of course, as a programmer or a data scientist or data analyst, you don't have to worry about optimization, right? You just want to like, oh, I do this, and then I will get the result. So that's why Polars take care of that for you. You don't have to, manually optimize it. Polars will just analyze your query and optimize it for you. So for you, your job is just to create or like a code that works. You don't have to worry about the optimization. It's automatically done.
Okay, so thank you for your presentation and cute slides as well. So yeah, I have several questions on my end. So first one is there any performance difference if we use Polars with Python API versus the Rust one, which is, I mean, Rust is the native one, right? So is there any performance difference? And then the second one is, I just heard about the narwhals actually, but I'm curious if does narwhals have any performance overhead, because it introduced a new layer on top of the existing data frame libraries, right? So I'm just curious about that. So probably the last one um, is there any use case that it's not suitable for use to use lazy data frame API? I mean, it's more. I mean, we prefer to use the eager one instead of lazy one. Is there any use case that?
So for the first question is about the comparing different APIs. I don't think there are people who actually compare using the Rust API and the Pandas API, but I can already tell you like the best is that like if you use the native one, of course it's faster, because the Pandas API they actually have this kind of it's using PyO3, so actually it's like there's a very thin layer of Python connecting to whatever the part written and compiled in Rust, but the difference is not that big because that layer is very, very thin. And also, why nobody's comparing those two is that like because you won't try to rewrite all your Python code or teach your team to write in Rust just to get that optimization. So just use it. It's good. The next question is what was the next question?
Narwhals. Is there any performance overhead?
Yeah, narwhals also have a thin layer, so it's another layer. But if you are using narwhals for Polars, the layer is super thin. If you look at narwhals code, because I also contribute to narwhals, if you look at the code, actually the interchanging between the narwhals API and Polars API is because they're two very, very similar. So again, like the layer is super, super thin. But if you use narwhals together with like, let's say pandas or other data structure, there are some, of course, like narwhal, you need to do some magic to convert that. But I won't worry too much about it unless you're doing something that's high performance calculation. So now it's more like something for your convenience rather than I'm trying to optimize the in production. Yep. So last question about the sorry, what's that?
The lazy data frame. I mean, is there any case that it's not suitable for us to use lazy?
So I would say that since Polar is still a very young project, and maybe there's some edge case they haven't tested. So sometimes I like if you see something weird when you are using like lazy API and then it's just not what you're expecting, then sometimes maybe change back to eager to see if there's a difference. Is it because like the lazy operation introduced some bug? I haven't personally found a case that is switch back to eager, but I'm sure like maybe someone I just haven't met that person yet, and they can like, oh, actually, I have to use eager for this, but I haven't encountered it yet. So yeah.
So you always go with the lazy execution one instead of eager. When
I think
everything you write
I
data
would
frame code,
prefer the lazy one.
prefer the lazy one.
But yeah, it also provided eager one. So like, for example, if I don't know, like, if just try to like use the lazy one if you can. But if you're like, if something weird happening in the lazy one, or like maybe you have to work or compare it with pandas, then maybe use the eager one or something like that. So, but I'm not sure. I haven't have a solid example for you.
Yeah, but it's still better than pandas, right? I mean, instead of
Yeah, someone actually there's a talk in Pycon DE I think last year. They compare like pandas with also the Polus eager API and Polus lazy API. So like the eager one is like I think 7 times faster, and the lazy one is 10 times faster or something like that. So yeah, so even just using the eager one also have a performance improvement in his case. Yeah.
Got it. Thank you.
Yeah. I think we are running out of time. Are we? Yeah, we're running out of time. So sorry. We can have questions and answer outside, or when you find me, I'm happy to talk to you afterwards. Yeah.
Thank you again, Ms. Chuk, for sharing your insight and answering our question. Let's give her one big round of applause. This concludes our session. We hope you have gained valuable tips for smooth migration to Polars and new ideas for optimizing your data workflow. Thank you, everyone.
Thank you.
Aku ngisi 2 lah, aku ada 3 lagi ya. Kemarin